All right, this is our last example from 14.4. Example number 3 asks us to do a little bit more with our implicit differentiation. It asks us to find the equation of the tangent line to this curve. So it gives us this funky equation, and if you could put it in your calculator or put it in Desmos, it would look something like the blue picture over to your right. So kind of this little swoopty idea. And it says here that there's a tangent line that touches at the point 2, 4. So this pink line is our tangent line, and we want to find the equation of that tangent line. If you remember from before, there's two things that we need in order to come up with an equation of a tangent line. The first thing we need, remember, is a slope. The second thing we need is a point. And so it actually gives us a point. It gives us the point 2, 4, but we're missing a slope. And so we've got to be able to find the slope of this tangent line. Ah, doesn't that sound familiar? What's another word for slope of a tangent line? Well, isn't it derivative? So what we have to do first is we've got to find the derivative of this equation. And because this equation is written implicitly, you've got x's and y's all intermingled, we should be able to use our implicit differentiation to find the derivative. Pause the video, practice this one, and see if you get the same derivative as me. All right, does yours look like mine? Remember, that looks like there's a little bit of a product rule on that right side there. Don't forget your dy over dx anytime you find the derivative of a y with respect to x. Let's clean it up a little bit. Let's move our dy dx's over to one side. Let's move everything without a dy over dx to the other side. Let's GCF out that dy over dx, and then let's divide so that we can solve for dy dx. I ended up getting the derivative, dy over dx is equal to 9y minus 3x squared over 3y squared minus 9x. Now it looks like you could reduce all those by 3 if you'd like to, all 4 terms by 3. Also, I want to tell you that if you moved it to one side and I moved it to the other side, your answer might look a little bit different. If every single one of the signs are opposite of mine, your answer is the same as mine. But make sure every single one is changed or opposite of mine. If that's the case, your answer is fine. You just moved it to one side when I moved it to the other side. Okay? All right, we're not done yet though. We want to find the slope when x is what? Well, when x is 2, right? Wasn't that the point that they asked us to find? And we want to find the slope, the derivative, when y is 4. So we should be able to use this derivative equation to find the slope by plugging in 2's for x's and 4's for y's. So what is the slope of my tangent line, the derivative at 2, 4? You should end up getting 4/5. Make sure you got that same answer. So hopefully you're pausing the video and working it out off to the side. But I got a slope, a derivative of 4/5. So now I have a slope, I have a point. You should be able to use your point slope formula to find me the equation of the tangent line. Try it. If I plug in my y, if I plug in my m, if I plug in my x, distribute, and I'm going to move that 4 over by adding it. But then I need a common denominator, so instead of 4 over 1, I'm going to multiply both the numerator and denominator by 5 and call him 20 over 5. So now I have a negative 8/5 plus 20 over 5, and I end up getting the equation of this tangent line as y equals 4/5 x plus 12/5. I need a slope, I need a point, so I can make my equation of my tangent line. But remember, in order to find the slope of the tangent line, that's the same thing as derivative. So practicing more of your implicit differentiation. All right, guys, let me know if you need